In this section, I would like to introduce you to simulating a hardware programming platform. So this is developed by Autodesk. The actual name of the platform changed quite a bit over the time. At the time of the recording, it's called Tinkercad, which offers 4 different simulations, including something called Circuit. So if you register for a free account for Autodesk Tinkercad, within that there is a Circuit a web application, and this is how it looked like. So you can drag and drop a lot of different components and start programming either using Arduino code, or it also provides something called blocks. Blocks are a programming paradigm, which we call visual programming. You drag and drop different controls and input output, and behind the scene it will be replaced by actual code. So when you drag and drop a block, and then there's an actual code written behind the scene. So the blocks are used for make it easier, but you can see on the right hand side the 2 loops and the Arduino code is written behind the scene. Right hand side you can see on the combo box Arduino Uno R3 is the one that you are programming. So this is the breadboard. So you can actually use this platform to simulate. It will actually do a pretty good simulation, including all the input output. It will light up, the fans will rotate. Even some of the components will be burnt if you put more current through it. It will simulate even burning out. There are a number of advantages of using a simulating platform like Tinkercad in comparison to using actual hardware. It is cheaper, so you don't have to buy all the components. It is faster because you can drag and drop, save and load very quickly. Convenient, you don't have to deal with managing hardware, cables, breadboards, powers. You don't worry about components getting burnt. And it's very non-technical friendly. And then also you can save any of the circuits you build. You don't have to another day rebuild everything. You can just copy paste. You can change quite easily. So it's a very convenient platform for you to learn and test. And also you will be using Grooved systems in your IoT labs. So you can use this platform to get experience of what an Arduino kit look like. The kit that has a breadboard, kit that requires you to do the cables and using resistors and manually managing all the current and voltage that goes through the sensor kit. Here I have put 4 different videos that each video explains some of the interesting circuits. Please watch them all. The first one is the introduction to the Tinkercad. It will explain how Tinkercad works, and there are 3 use cases or applications people have developed related to 3 different application scenarios using Arduinos. Please watch all of them. I just want to give you a very quick overview of this platform called Circuits in Tinkercad. So here you have a blank canvas, and then here you have different components. You have select all or basic. Microbit is another type of Arduino microcontrollers. Here you can have different Arduinos already being put together, but you can manually build your own. So if you select all, you can see resistors. Once you click it, there are different configurations you can make. There are input-output devices, push buttons, flex sensors, ultrasonic sensors, motion sensors. At runtime, you will be able to simulate any motions here. Even keypads, so you don't need to buy any of these things. And then there are outputs, LEDs, different types of lights, and there are motors, different type of motors, remote controllers, power, battery. Even there are funny potato batteries. And then breadboards, so you can drag and drop a breadboard. There are commonly used microcontrollers. So Arduino Uno is the one that you get with the Arduino kit, very popular. So you can directly drag and drop and connect whatever the way that you need. As far as I know, it does not validate. So if you do something wrong, either it will not work or either it will show that it's burning. Either way is fine because it's virtual, it's much easier, convenient, because imagine that you have to do this manually, having these cables. At the beginning it will look like fun when you're doing it practically, putting the cables and clipping it. First few days it would be fun, but after that, believe me, it is not really fun because you're doing the same thing over and over again. So my suggestion is, if you get to play around with the Arduino kit, maybe do it. But after you get to know it, the online version is, the simulation is much better, because once you run the code, once you finalize the code is working, then you can pretty much buy the hardware and do that. The only downside of this platform is it has quite a lot of hardware components, but not all. So especially when you're developing an IoT solution, especially it is new, you'll be using very specialized components to achieve the task. You may use some generic components like motion sensors and gas detectors, but when you're really developing some IoT applications, you probably try to buy some specialized components. For example, if it's a gas, like you will buy maybe a little bit more expensive, but there are very sensitive, specific type of gas sensors. So you have the 8-pin headers, USB connectors, different logics. So these are all the components. As you can see, it's a fair number of components, but by no means it's complete, because in Arduino ecosystem you can find quite a lot. And again, this is Arduino, not Raspberry Pi. So if you want to Raspberry Pi connected to sensors, you still have to go and do it manually using breadboards or using Groove systems. And when we come to coding, there are two views. I think this is the drag and drop view. So you have variables, declare, mathematics, control structures, if else, count, loops, whiles. So then you can have input, output, readers. So you can actually have this kind of programming, which we call Blocky. So if you search on Google on Arduino Blocky, you can find another platform, another multiple platform that actually provide you the ability to write programs using drag and drop. So this part, the visualization part, will not be there, but those platforms targeted on helping you to write the programs. So here it is a complete visualization package, but there are other platforms. You can search on Arduino Blocky, which will allows you to write drag and drop components, and automatically in the behind the scene it will write the code. So here is a block, then you can change it to the block and the code. So you can, here it is representative. I think if you change this one, it will change automatically here. If you change these numbers, I think it might change the delay time here. So it is basically, you can learn by doing that. And then you have the text version. You can go and just edit as much as you like. So this is the one that you actually should use, because Blocky is good to learn at the beginning, but it might have limitations, and after some point you get annoyed because they are too complicated. But writing code is much easier. But at the beginning it will be much attractive and fun to work through the blocks. And then I think if you run simulation, I might be able to show, like, yeah, there are some gas. So basically you can move, I think the PIR, yeah, so there are each sensor has some kind of a way to activate it or visualize it. So then you can know it is on the period within the space that it will trigger. So basically it is covering this area, so if it is put there, it will detect. So each component has some kind of simulation mechanisms, and I think I saw that it will also get burned if you put more current. So please have a look and give it a try.